You are listening to a WhiteHat security webinar. This is the ghosts of XSS past, present, and future. We'll be discussing defensive theory around cross-site scripting and how to stop that risk in your web applications. My name is Jim Manico. I'm the VP of Security Architecture for WhiteHat Security. I'm also a volunteer for the OWASP Foundation, and my background is primarily in software development. This presentation is specifically for web developers who are trying to build web applications that are free of the risk of cross-site scripting. So cross-site scripting, why is this risk so serious? Now, in the first place, cross-site scripting is when an attacker can trick a victim into executing malicious JavaScript. And this is JavaScript that was never built in the website in the first place. This is JavaScript that the attacker submits through a URL or submits through posting to a website in some way, and that malicious JavaScript is then executed by a victim. This is the OWASP 2 out of the OWASP top 10, and in my opinion, it's a very serious threat. It's something we look for every day at WhiteHat when we do our work. But the key is that this risk comes up so often that I see a lot of managers who brush it under the rug. You can fix one easily, but fixing every cross-site scripting flaw for every application is a serious challenge for any large organization. But here are some of the things that an attacker can do with cross-site scripting. First one, session hijacking, simple call with malicious JavaScript that says document.cookie, and once you have that cookie data, you exfiltrate it through a technique using like window.location or put it in an image tag. It's relatively easy for an attacker to use JavaScript to do session hijacking. Of course, once the attacker gets that session cookie, he can steal this session ID out of it and then use that to hijack any active session. An attacker can also use cross-site scripting to do site defacement. Really simple call, document.write or document.body.innerHTML, and bang, the entire page is modified any way the attacker can think up. Cross-site scripting can be used to undermine any form of cross-site request forgery defense by stealing tokens and using that token for additional transaction. Cross-site scripting can also be used to redirect a user and help enable phishing. Cross-site scripting can be used to steal pretty much any data on page. You can even use cross-site scripting to set up events to trap key up and key down events to become a full keystroke logger. It is a serious threat. There are so many things an attacker can do with cross-site scripting. It's something we need to take seriously if we want to build a secure web application. So let's start with the past. Let's look at what the security industry told developers in the beginning when we first started building websites, when we first found cross-site scripting as a risk. And let's look at the history of what developers were told, and we'll work our way up to today. I think by going through the history of cross-site scripting defense, we'll understand a bit more why this is such a problem, and we'll also understand more of what's really needed to defend against this risk. So when cross-site scripting first came about in the early 90s, the defensive strategy that most security people told developers was to eliminate dangerous characters, especially the big five: less than, greater than, ampersand, and single and double quotes. These characters are used to drive HTML markup in a pretty significant way. And so when you tell a developer to eliminate these characters, or disallow certain user input, or build a global filter to strip out all these characters from all input, let me ask, why does this strategy not work? Because it doesn't work at all. Just eliminating dangerous characters is never going to work, and here's why. First of all, we need to accept dangerous characters and display them to users. That's just the way the web works. When you have two accountants talking, they're going to use the less than or greater than sign. Ampersand comes up all the time in conversation. Single quote is critical. Hey, you drop the single quote, you just upset all of Ireland. You need the O'Malleys and the O'Sheas to have that single quote inside of their last name for proper internationalization. And so just stripping out dangerous characters, it never worked before, it's not going to work today. So simple input validation of stripping out dangerous characters is just not going to work. We need something better. We told that to developers when this risk first came about. Didn't work then. It's not going to work now. And so Let's look ahead to about year 2000 now. Around year 2000, the security industry and the application security community started to understand that input validation is not going to be enough. So we began to talk about output encoding, in particular, HTML entity encoding. And this is a huge step in the right direction because this is critical. Input validation for string input is never going to be enough to stop cross-site scripting. It doesn't work. It may help reduce the risk a little bit, but it's not going to stop cross-site scripting 100%, and that's my goal in this talk. So as we shifted to output encoding, this is a step in the right direction. We're basically taking these dangerous characters like the less than sign and converting them to a safe version. In this case, it's being converted to the ampersand LT semicolon HTML entity equivalent. Now what this means is when the HTML parser in your browser sees a less than sign, it's going to think you're starting a new HTML tag. But when the HTML parser sees an ampersand LT semicolon, it's just going to display a less than on the page without thinking it's the start of a new tag. So the ampersand LT semicolon is the safe variant of the less than sign. And this technique, output encoding, converting potential malicious, untrusted data to a safe format, this is a critical concept as we discuss cross-site scripting defense in depth. But even this strategy is not enough. Even this strategy is not going to work in today's web applications. And the question I have is why? Why is HTML entity encoding not enough? Well, the answer is multiple contexts. Based on where data lands in an HTML document, we have to encode that data differently. If we put data in the HTML body, we want to do an entity encoding. But if we put data in a cascading style sheet style context for a cascading style sheet value, then we need to encode and validate. We want to do strong structural validation, and we want to do proper cascading style sheet hex output encoding. Or if data lands in a script JavaScript variable assignment context, we want to do JavaScript hex encoding. And if it's a get parameter in a URL, we want to do percent encoding or URL encoding. So that's why the advice of HTML entity encoding, it's just the tip of the iceberg. It's just the start. We need a different kind of encoding or validation or sandboxing or defense based on the context of display of that data. And also based on the type of data that we're managing, we'll need to deal with a different kind of defense. We'll talk about that soon. So now we're getting a little bit closer to today. This is around year 2007. This is around the time when the ASAPI library came out with the encoder, and we see a series of different encoding libraries with different contexts showing up. And this advice is reasonable. Step one, we say you should first canonicalize data. We should decode input to its simplest form to help mitigate the threat of attacks being encoded to evade filters, step one. Step two, we do want to do validation. It's a great thing. We want to do positive regular expressions, whitelist regular expressions. We want to define what good input is and reject everything else. And then when we display this data in a user interface, when we, as a programmer, take untrusted data and put it into some kind of user interface template that drives an HTML document, we want to encode differently based on the context of display. HTML entity encoding, percent encoding, cascading style sheet hex encoding, JavaScript hex encoding are the main ones that we're going to want to deal with. And so this is a reasonable piece of advice. This is circa 2007. These are the different defensive techniques we need for each context, but even this is not enough. Even contextual output encoding is not enough in the modern era of rich internet applications and heavy JavaScript applications and JSON parsing and HTML input from TinyMCE and all these different edge cases that the security industry, by and large, doesn't talk about enough. We're going to talk about that today, though. I got some bad news. What we're doing today overall is not enough to stop all cross-site scripting. And what do we want to do? We want to stop all cross-site scripting. Here's an example of an interesting edge case where even when a developer is doing proper cascading style sheet output encoding, as we told them to do from the ASAPI project, they still have a cross-site scripting vulnerability. In this example, the developer is taking untrusted input. They are encoding it using cascading style sheet hex output encoding. They're putting that encoded data in a simple width in the style, and then we see on the third line, we see what actually the encoded data looks like. Even when you have encoded untrusted data, if it's an expression, which is only supported in IE, it will still pop. This is a really esoteric edge case, but if we want to stop all XSS, we need to care about these esoteric edge cases. Now, of course, IE has stopped supporting the feature of expressions because it is a dangerous feature because of problems like this, but it still pops in IE6, IE7, and IE8, at least in Quartz mode. It's something we still want to be concerned about. The goal here, or the point I'm trying to make here is, in many situations, output encoding is not enough to stop cross-site scripting in depth. And so let's look at some other research from Adam Barth. Adam Barth is a really smart person. He's a really sharp individual. I mean, no disrespect here. But here's some key advice that we saw from Adam Barth just a couple months ago. He said, and this is very similar to how modern Web 2.0 plus applications work. He's saying, step one, on the initial page load, it should be static content only. And then two, start making JSON requests via AJAX, and then once you get that JSON response data, parse it, and then rip it apart, and then place it in the document, in the DOM, using these three relatively safe methods. We have node.text content to populate text of a certain node in the DOM. We have document create text node to build a new text node, and element.set attribute. That element set attribute concerns me a lot. Element set attribute is one of the most dangerous JavaScript methods that there is. You could have a real simple attribute on click, on blur, and these are all JavaScript code execution contexts. So if we put untrusted data into an attribute, and that's an on click or on blur attribute, it will easily pop. We also have to do special defenses when dealing with the source attribute or an href attribute. These are URL contexts and mandate a whole different kind of defense. So we got to be careful when we oversimplify how to stop cross-site scripting. And this is a real key debate. What do you want to do? Do you want to stop all cross-site scripting and provide developer with the complete package of information? Or do you want to give the developer simple information and get 90% of the way there? In my opinion, I want to get 100% of the way there, which is why we're having this conversation. So let's talk about my vision of what XSS Defense is today. And it's a bit more complex than I wish it was, because frankly, there's a lot of different defensive techniques we need to really get this right. I'm going to go over this a couple times. So if we have untrusted data in the HTML body, we want to do HTML entity encoding. If we have untrusted data in an HTML attribute, we want to do at least minimal attribute encoding, in addition to probably encoding the space as well, because we may have an unquoted attribute where even a space can break out of that context. We may be putting untrusted data in a URL as part of a get parameter value. That's the only time we want to do URL or percent encoding, and I very often see that misused or used for a complete URL. If you encode a complete URL, you break that URL. It's no longer linkable. Or suppose we have a full URL that a user has submitted to your application. Suppose we're on Twitter and we're tweeting URLs back and forth, and then that URL, Twitter takes that URL and converts that text into a linkable URL, and that's actually quite a complex process. You want to canonicalize that URL, validate that the URL is a legal URL, avoid JavaScript URLs, or better yet, whitelist, so you're only accepting HTTP or HTTPS URLs. You want to do attribute encoding at the time you're presenting it or rendering that URL into an href tag, and you may even want to do some kind of safe URL verification to make sure it's not a malware URL. So honestly, managing a URL to stop cross-site scripting is a very tricky piece of code in my opinion. Or what if untrusted data lands in a cascading style sheet value context? I prefer you to design around it and avoid putting untrusted data in a CSS value, but when you have to, it's really validation that's the more important technique here. Really strict structural validation specific to that exact value type, in addition to CSS hex encoding for good hygiene. Now suppose you have untrusted HTML. Suppose your input's coming from a tiny MCE widget or CKE editor, which is a rich text editor. It converts the text area into a little mini version of Microsoft Word. You can bold text, you can highlight text, you can color things, bullet points. When you use one of those widgets, it submits your data as a chunk of HTML. And if you output and code that HTML, it's going to stop rendering. If you try to write a regular expression validator for HTML, good luck with that. That will require a pretty big regex that may be harmful in and of itself. So what we need is some kind of HTML policy-based validation. In the world of Java, we have the JSoup project, we have the OWASP anti-SAMI project, and my favorite, the OWASP HTML sanitizer project that was donated from Mike Samuel from Google. A real high-performance HTML sanitizer, so it will strip out any JavaScript that may be embedded in that untrusted HTML. We also have the whole issue of DOM-based XSS, and that's a whole nother set of defensive techniques we need. Avoiding certain APIs, having a proper workflow of our JavaScript variables inside the DOM, avoiding certain ways of rendering data. It's very, very tricky to avoid DOM XSS. We also have untrusted JavaScript, like when we're accepting a third-party chunk of JavaScript, which we do all the time from because of advertising or Google Analytics and the like. In that case, we want to do some kind of sandboxing. Suppose we're parsing JSON on the client, which is really common. The inventors of JSON, or the authors of JSON, they told us to use eval to parse JSON, which is incredibly fast, but unfortunately, it's not safe. It's XSSable. We want to make sure that we're parsing JSON in the browser using a proper JSON parser, like json.parse or json2.js for older browsers. And last, when we are putting untrusted data into attributes, we really want to make sure we're only doing it into safe attributes like I have listed here. There's definitely a large number of attributes like the event handlers which are never safe to put untrusted data in. Let's talk about this one more time. Let's go through these list of items just one more time quickly. So there's also the problem of dangerous context that can never accept untrusted data. Here we have untrusted data landing inside of a tag. It's not an attribute, it's just inside of a tag. We can never do that in a safe way. There's never a reasonable use case to do that in a web application anyways as a developer. In the second case, we have untrusted data landing in an eval function, which is basically cross-site scripting as a feature. This will just directly execute whatever is sent to eval as if it was JavaScript, and it will execute. So these are some examples of things that we can never do in a safe fashion. So let's look at the HTML attribute context again. This is an example where we have untrusted data landing in a div's ID. Number one, we want to escape all non-alphanumeric data with the HTML entity encoding standard here. And the thing is that we want to be very aggressive when we encode an attribute, because as you see here, this is an unquoted attribute. It's very simple for the attacker to escape out of that attribute. A simple space will do it. Also, we want to make sure we're only putting untrusted data in this list of safe attributes. It is this specific rule of output encoding is not okay for complex attributes. Here's an example of cross-site scripting in a source attribute. Here we have the image name, mymap.jpg, being placed directly in an image tag. Now, even though this is an image, make no mistake, this is a complete URL that's being put into a source attribute. So if we're expecting a full URL here, we want to, again, canonicalize the URL, make sure it's a legal URL, make sure it's a URL of only a safe type, HTTP, HTTPS. We want to do attribute encoding at the time of placing that URL in the source attribute. And if we have to accept a feature like this, where we are accepting a relative URL or just a flat resource, we have to do contextual validation specific to our application to make it safe. And this is relatively tricky. There's a lot of things that can go wrong here, but this is the kind of defense we need in this kind of situation. Or suppose we have HTML input. I mentioned this earlier. You may have tiny MCE. You might be using CKE editor. This is when users can edit a text area with rich text. They can bold items. They can use bullet lists and numbered lists. That rich text editor, TinyMCE and CKE editor, they submit that rich text as markup, as simple HTML. And so when we receive that untrusted HTML on the server, we want to use some kind of HTML policy engine that makes our HTML safe. In the PHP world, we have the HTML Purifier project, we have the Java JSoup, the Java OAuth Anti-SAML project, my favorite, the HTML Sanitizer project for Java. We also have HTML sanitization built into the .NET Anti-XSS library. This special tool is available for developers in almost every language. Or how about percent encoding? Here we're taking untrusted data, we're placing it in the get parameter of a URL, and I'm using JavaScript. I'm using JSP, Java Server Page notation here. So we have untrusted data. It's landing in a get parameter value within a URL. In this case, all we need is percent encoding, URL encoding. That's just part of the URL, URI standard. It's how you build a URL anyways. And this will stop XSS at the time of placing that untrusted data into the URL. Now, just as a quick note, so you may then want to take that complete URL and then attribute encode it at the time of placing it into an href tag, right, for a little extra defense. Here we have an example of untrusted data landing in a cross-site scripting style tag. I'm sorry, here we have untrusted data landing in a cascading style sheet style tag. So we have the color white, it's landing in background color, and because of those problems with expressions, this can be even if you do proper output encoding, this exact feature can still pop XSS in certain variants of IE. So to really stop XSS here, we want to do really strict validation, or we want to design around this feature. For example, if we want the user to pick a background color, we may do that on the client where they can pick from a list of safe colors. We'll dynamically modify the client without even going back to the server. We see this in news articles where if you want to change the font size of a news article, they very often give you an up or down arrow to increase the font size. This lets the user dynamically change the style of the page without having to do a round trip with the server and worry about untrusted data landing in these dangerous contexts. But if you have to do this, you want to do cascading, style sheet, hex output encoding, in addition to incredibly strong structural validation of untrusted data. And yep, here's the defense I just talked about. Here's, again, another cascading style sheet style. We do the output encoding with hex format. We do the proper input validation, and strong validation is going to win the day here. How about JavaScript context? Here we have untrusted data landing in a JavaScript variable context. Now, at the time of rendering this variable, we want to do JavaScript hex encoding. That's the /hex format up above here. But this is not enough. This will stop XSS at the time of rendering that variable. But the real question is, and the deeper and more complex question is, what happens to that variable after you assign it? And so here's an example of untrusted data landing in that code execution context. We have eval, we have set interval, we have set timeout, and all of these will take untrusted data, automatically decode it, and then execute it like JavaScript. Again, even JavaScript encoded untrusted data will still execute in this type of context. So we need to do something better here. Also, we have the jQuery library. jQuery is one of the most popular JavaScript abstraction libraries out there. It makes it really easy for a developer to build some incredibly rich interfaces. It also makes it easier for the developer to support all the JavaScript quirks that we find in a cross-browser development environment. So rather than having to do all these special hooks for different browsers like we've done in the past, if you just use jQuery, all of those browser-specific quirks are built in. Now, unfortunately, the vast majority of jQuery is vulnerable to XSS. The vast majority of jQuery methods that directly update the DOM will take that data and just render it directly without any kind of encoding. This is a big problem. It's a heavily used library. All of their syncs are vulnerable for the most part to XSS by default. We need to do something special to stop XSS deep within the DOM. And Jquery, written by Chris Schmidt, Jquery has an encoder. This is the Jquery embedded encoder that will let even a deep JavaScript developer who's dealing with JavaScript variables that are traversing the DOM in some rich internet application, they can still do contextual encoding inside of JavaScript itself. Unfortunately, we need this to stop XSS in depth, specifically against the DOM-based XSS risk. And this makes XSS Defense outstandingly complex. And I see very, very few shops who go as far as using this tool to stop the deeper risks. And frankly, we have to in order to stop all XSS. So here are some other best practices to stop DOM XSS. Number one, untrusted data should always be displayable text when traversing the DOM. We want to be careful of using JavaScript variables and untrusted JavaScript data as workflow variables and non-displayable text. We also want to make sure that we JavaScript encode and quote untrusted data when we place untrusted data in a JavaScript variable. We want to use these safe APIs, but be careful about set attribute. Make sure you're using set attribute for safe attributes only. We also want to avoid the HTML rendering methods like inner HTML, and be really careful of the eval and other code execution context functions. Eval, set timeout, set interval, and then the different attributes like onClick and onBlur. All of these are code execution contexts that should never have to directly deal with untrusted data. So that's where we are today. And frankly, it's a challenge. It's frustrating. There are very few teams who can eliminate all XSS continuously as part of their development cycle because of all these quirks that one has to deal with. But there's hope. I think there's hope. I see a lot of emerging techniques and standards and tools being built for developers that will make it radically easier to stop cross-site scripting. So first of all, we have JavaScript sandboxing. One of my favorites is the HTML5 iframe sandbox. This is a new feature in HTML. It allows the developer to specifically lock down one individual iframe, load the data into that iframe from any source, and set policy on that iframe. So even if malicious JavaScript is in there, it just will not execute. And there's policy to let the developer granularly set policy on what can execute in the iframe sandbox. There's also the capabilities, JavaScript from Google, the Kaha project. This is heavy lifting, but it's a massively awesome project that basically subsets the entire JavaScript language, adds automatic static analysis into your workflow of your application, and also builds client-side defenses into JavaScript to help some of these more dangerous APIs. It's heavy lifting. It's a great project if you start from scratch from day one developing against the Kaha project. It's quite challenging to embed it after you've gotten started, however. We also have standards like content security policy for Mozilla. This is a pretty outstanding standard, and it's already supported in the Firefox browser. They converted content security policy to an actual W3C standard, and we see other browsers beginning to work on implementing content security policy. We also have ECMAScript 5 object sealing, where we can initialize a JavaScript object and then seal it or lock it in a variety of ways so it can't be modified. So all of these are types of JavaScript sandboxing that's going to make different types of XSS and attacks on your application much, much more difficult, if impossible in some cases. So let's talk about the Google Kaha project for just a moment. So Kaha will sanitize JavaScript into cajoled JavaScript. And Kaha uses multiple sanitation techniques. First, on the server, Kaha uses static analysis when it can to make sure that your assembled JavaScript doesn't have any obvious flaws. And if it does, it will literally break the application. It will stop working. So you want to make sure that before you actually roll your application live, that your static analysis pass in Kaha has been done cleanly. So, and then the second piece of Caja is that it modifies JavaScript on the client to include additional runtime checks for additional defense. Again, this is a huge, massive, heavy lifting project, but it's the kind of defense we need to make it easy on the developer to stop cross-site scripting. We have a different technique out there called auto-escaping templates, and these aren't ready for prime time yet, but I see a lot of work being done that really gives me hope that we're going to give tools to developers which automatically stop cross-site scripting. So first we have, again, the context-sensitive auto-sanitization template project from Google. This is one of the oldest auto-escaping projects out there. This is it originally started as a high-performance C++ HTML template language, and what it does is it automatically detects the context of every variable being dynamically added to that template, and it will apply a different encoding technique based on the context of display automatically. This is brilliant. So if a developer uses this particular template, he can just rock and roll. And if he places data and in the legal context, the template won't compile. Otherwise, the template will just automatically add the defense for the developer. That's ideal. The developer can get back to rocking and rolling and writing code. The template will add the security for the developer. That's the top of the mountain, I think, when it comes to secure coding in general. We have a long way to go to get there, though. There's also the Java XML template project from Jeff Ikonowski from he donated it to the OWASP Foundation. This is a very fast and secure XHTML compliant, context-aware, auto-escaping Java server page-like user interface template. And the cool thing about this project is Jeff has gone to the point where he's added so many different contexts, many more so than I've seen in any encoder. We're actually ripping his encoder out of this project and building it into a separate project because even the best of breed encoding that we know today, it needs some work. There are additional encoders that we need to solve all the contexts used in a modern application. And here's a great thing. We have Ivan Ristic, who's been modifying the Apache Velocity project. This is an existing, well-used template language for Java, and he's going into that project and automatically adding the auto-escaping so anyone who's already using this template will get the benefit if they use his add-on. It's not done yet, but that kind of thinking is excellent. Let's take an existing legacy technology and let's try to build that security in to help stop cross-site scripting. Go, Ivan. So we also have content security policy. This is a standard. Robert Hansen first worked on this, and then Brandon Stern from Mozilla did the implementation in Firefox and helped fine-tune the standard. Content security policy. Step one, you need to externalize all of your JavaScript. You push all of your JavaScript to .js files and then define a policy for your site around which JS files are legal to execute on the site. And that's part of the Content security policy response header, which tells the browser which JS files are safe. And content security policy runs in two modes. It runs in a mode that blocks a potential vulnerability, or it runs in a mode that just audits and alerts if it sees a vulnerability. It's good to run your website in alert mode first until you got everything working very well, and then shift to production mode, into blocking mode, because CSP can break things in some cases. And this is a great standard. It's decent, but it's going to take several years before all browsers support it. So it works in Firefox today, but it's going to take a while before we see it in Chrome and we see it in IE and for most users. But it's a step in the right direction. Thank you so much for listening, and any questions, please drop me a line. I want to thank all of these wonderful researchers for doing work to help stop cross-site scripting. And again, thank you for your time. Go forth and build secure web applications. Have a great day, everybody.
Hello and welcome to the walkthrough of the Sentinel online portal. My name is Justin Beechler. I am a solutions architect with WhiteHat, and I'm going to be taking you through the features and functionality today. To give you a little background on WhiteHat, in case you don't know, we are a web application vulnerability assessment platform targeting layer 7 or your application-specific vulnerabilities. To begin here, this is the executive summary page. This is the first page you would see when logging onto the interface. And what it serves to do is provide you with a 10,000-foot view of any applications that you have under assessment and some relative information as far as your general security posture. So on the left-hand side of the table here, we have a couple of demonstration applications set up in the interface here. And then to the right of that is a two-letter acronym in accordance with the service line that those applications are being assessed under. We have BE or Baseline Edition, SE or Standard, PE Premium, PL is Pre-Launch Edition. And to touch a little bit on each one of those, it really has to do with the comprehensiveness of coverage that you want on your application. So BE or Baseline Edition is going to be an unconfigured, unauthenticated assessment of your application. It's great for marketing sites, static sites, sites that you don't need to go too in depth, but it'll prevent against anything that an automated bot would find on the internet. SE or Standard Edition is going to give you a fully configured and authenticated assessment, looking for all the technical vulnerabilities. So cross-site scripting, SQL injection, anything from an automated perspective will be found with the Standard Edition. PE or Premium Edition is going to give you the fully authenticated and configured automated testing that Standard Edition does, and in addition it will provide you with business logic testing. These are design-specific issues that are tested by hand, looking for authentication, authorization issues, session management, anything that a computer can't be programmed to do, anything that involves a judgment call is under the business logic scope. And then last is PL or Pre-Launch Edition. This is our service line that's targeting specifically QA environments. It's got a very aggressive testing profile and real quick turnaround times. But the difference between the PL or the pre-launch and the baseline, standard, and premium editions is the production safety. Because PL is very aggressive with its testing, we do not recommend it for production applications, only for QA environments. However, the other three service lines can be applied to both QA and production environments. To the right of that is the industry rank. One of the benefits of assessing as many applications as WhiteHat does is we get the opportunity to compare you against all other companies within your same vertical. So taking the number of vulnerabilities found on those sites and comparing you to the other companies in that vertical give you an overall industry rank. The more vulnerabilities, the lower down on the industry rank you're going to be. Industry is something that you can set within the portal here and set yourself to financial services, IT, manufacturing, whatever vertical you believe you belong in. This will allow you to compare yourself to those sites. To the right of that is the findings, and this gives you a quick look at the number of vulnerabilities found, broken down by the severity or business impact. So here we have 16 urgent issues on this demonstration site, 27 critical, 15 high, 0 medium, and 0 low vulnerabilities. To the right of that is the scan schedule. This is one of the 3 key pieces of information that we need from you in order to begin assessing. One being the URL of the application, 2 being the scan schedule or the window of testing. You get to tell us when you want us to be assessing your application. We recommend 24/7. There are nights and weekends available and custom scan schedules. If you only want to have us test 3 hours on Friday and 4 hours on Saturday, that's completely within your control. The third piece of information that we need is testing credentials if your site does contain authenticated content. To the right of that is the scan status on the far right of the columns here. And this is a red light, green light system that basically alerts you if there's any action needed on your end in order for you to be getting full value from the service. As we can see, 3 of the sites here have a green light saying that a scan is running. We have a scan schedule, we have credentials, and we've got the URL, so we're all set to go there. If you were missing any one of those pieces, you would see a red icon here indicating that an action is needed on your side in order to be getting full value. Above there is a configuration in progress icon, and that's just simply letting you know that the Threat Research Center is hard at work configuring the site to get as deep and as wide as possible and really get that comprehensive coverage. Scrolling down below the table here, we see a lot of fun little charts and graphs. And this is really one of the benefits of having an annual subscription or an ongoing assessment, is you get this trending information along with it. So from a month-to-month perspective, I can actually see, am I introducing more vulnerabilities? What month was that? Did I have a big, big code release that month? It gives you a lot of insight into whether you're getting worse or getting better with your security posture. Also, it gives you a lot of information about the vulnerability classes specifically. So I can see here I have 38% of my vulnerabilities are cross-site scripting. That's a good indicator for me that maybe my developers need a little bit of education as to why cross-site scripting is not a good thing to have, how to write secure code with cross-site scripting in mind to prevent against it. Scrolling back up here, clicking any one of your applications will allow you to deep dive into that application specifically and view a lot of this similar information but on a per site basis. So you can see here the number of scans completed in the last 30 days for this demo site. The site priority. Now this is something that you can set in the settings option at the top here, and really what this allows you to do is assign a business criticality to the application itself. So if this is my flagship application, mission critical, I'm going to assign this to be a 9 or a 10, whereas maybe one of my marketing sites that doesn't have as much traffic or focus on it, I'm going to put to a lower priority. When we view the findings in just a minute, you'll see that this site priority actually goes into the overall vulnerability score so that you get your most damaging vulnerabilities on your most critical business applications as kind of your top priority. To the right of that is the global and industry ranks. Global is essentially the same approach that we took to the industry rank, except now we're comparing you against all of the sites that we assess and not just the ones within your vertical. Scrolling down here, we have a lot of the same trending information that we had on the main page. This time it's for this site specifically and not for all of the sites. Scrolling back up to the top here, I'm going to open up the findings here. And the findings is the meat and potatoes of the service here. So some of the differences in the way that WhiteHat does things as opposed to your traditional desktop scanners is we like to organize our vulnerabilities into developer-friendly buckets. So what does that mean? That means if you've got a registration page that has a username and a password field on it, we're going to flag that as one vulnerability. Let's say they're vulnerable to cross-site scripting. One vulnerability for cross-site scripting, and we're going to flag each one of those parameters as an attack vector of that vulnerability. We figure that if developers are going in and fixing things, they're going to fix by page or feature set or form rather than by individual parameter. Each vulnerability is tagged with a unique vulnerability ID number that will never be duplicated, and it'll be there for the life of the vulnerability. So that's a great little reference point. Even if you were to fix the vulnerability and then revert your code and it closes out the vulnerability and then reopens it, it'll have the same vulnerability ID number. So that's a great little tracking method here. To the right of that is the retest. The retesting you can run on the fly, happens in real time. Any automatically retestable vulnerabilities will have a green check mark here. Any manually retestable vulnerabilities, so you talk about your business logic issues, things that can't be automated, you'll see a little hammer icon here that will indicate that that one has to be done by hand. But any one of these automatically retestable vulnerabilities here with the green check mark will run at the beginning of each scan of your application. So those will retest automatically each time. It's just for the business logic vulnerabilities. As you fix them, you can run in and retest these. A lot of this other information is pretty straightforward. When the vulnerability was found, the site that it was located on, the class of vulnerabilities. So here at WhiteHat, we operate under the WASC, or Web Application Security Consortium, class of vulnerabilities. And that's got all of your big doozies, your SQL injections, your cross-site scripting, content spoofing, insufficient authorization, session fixation. You know, we hit all the big ones. To the right of that is the risk metrics. So when each of these vulnerabilities are validated by our Threat Research Center, they make a couple of determinations. One being the severity or business impact. 1 through 5, 5 being the most impactful. So we can see SQL injection here, obviously hugely damaging to a business. That receives the top billing at a 5 here. To the right of that is threat, and threat is ease of exploitation. How easy is the exploit to pull off? Again, 5 being the easy exploit, 1 or 2 being something a lot more difficult, would require maybe leveraging another vulnerability in order to make anything actionable happen. And then to the right of that is your site priority, and that's the value that you get to set that influences your overall score to the right of that. So severity plus threat plus priority gives you your score. The reason this is handy is because if you're looking at 200 vulnerabilities that you need to remediate, sorting by score gives you a great indicator of, okay, these are the most damaging attacks on the sites that I care the most about. So that's a great starting point. The far right column, details. That allows you to deep dive into each attack specifically and view some more information about that particular attack. So here we have cross-site scripting vulnerability. We can see here it was found on the datareceptor.php page. It's got all the information from the table that we just came from, retesting options, and then right below that is a little link called Ask a Question About This Vulnerability. This is a great little link, widely utilized for vulnerabilities that are a little bit more complex in nature. What this allows your developers to do is click on this and open a communication dialog right below the parameters here with the security engineer that found this vulnerability. It allows them to ask for extensive exploitation steps, questions about remediation, pretty much whatever they want to ask. They can have a direct dialogue with the engineer. By default, we push a description and solution and references for each vulnerability that we find. 99% of the time, you're going to find all your answers within this section here. But for those complex issues, our customers have found that this Q&A session here is a great little benefit. Scrolling back up to the attack vectors. So in my previous example of a registration page, this would be like the username field or the password field. It'll show you the injection that we made. And for those of you familiar with cross-site scripting, you might notice that this doesn't look like a typical cross-site scripting injection. This is one of our production-safe methods here, as we use benign injections to test. Seeing this reflected back gives us a good indicator that there may be the existence of a cross-site scripting vulnerability, and our Threat Research Center engineers go in and they validate by causing an alert or a prompt to happen, and they will validate that it is an actionable vulnerability and push it to the interface here. If you want to see exactly what that looks like, there's a little details icon here, and you can dive into this one particular attack on this parameter and see, okay, what was the request being made, and then what was the response that came back. And we even highlight within the code where the injection is falling. Sometimes it falls in multiple places for your developers to kind of see what's happening there. Okay, moving on to the reporting tab here. We have a couple of different reports available by default. We have the executive report, which is going to give you access to all the pretty charts and graphs that we saw on the very first page. The site summary report is going to provide you that same information, but it's going to go a little bit more in depth as far as each site specifically, what vulnerabilities are in existence for those sites. Doesn't go into detail as far as what attacks were used or where the vulnerability was located. Just a brief, I have 5 cross-site scripting vulnerabilities, I have 6 SQL injections, etc., etc. Below that, the vulnerability detail and attack vector detail report. These are your developer-focused reports. This is going to give you all of that injection information, where the vulnerabilities are located, the descriptions and solutions that we saw before. All that information can be accessed on these reports. And there's a multitude of different filters that you can do if you want to do it only for the last couple weeks, for specific sites, for specific vulnerability classes, etc., etc. The last 2 reports available on the fly are the PCI report, which essentially shows PCI compliance and how you stack up against those different standards. And then Site Security Statement Report is a really high-level security report. Who is WhiteHat? What do they do? What do they test for? How many urgent, critical, high, medium, low vulnerabilities do I have on my application? So this is great for third parties that are interested in what you're doing as far as security. This gives them a very basic understanding of what we're looking for and gives them that peace of mind. Touching on the admin tab here at the top, one of the benefits of Sentinel here is we don't charge per user. There's no limit to the amount of people that can have access to this information. You can set up your entire development team with access to Sentinel to view this information. You can set it up so that only your security team has access. Another great benefit of Sentinel is that all this operates on an open API. So if you have bug tracking systems like Jira or Bugzilla, WAFs like F5 or Imperva, GRCs like Archer, SIMs, whatever systems you're currently using in-house, as long as it can take that XML data, we can integrate with that. So for WAFs, for example, it can pull this vulnerability information into that WAF and set up those blocking rules specific to those attacks. So it's a very cool and powerful tool, the API here. As far as the users go, it's really setting up a new user is as easy as hitting the new button, filling out the email address of the user, and then assigning them access to particular sites, and even limiting the functionality they have access to. So you can give them a viewer-only role, a developer role, which has report generation and retesting of vulnerabilities. The security operator is going to give them everything that a developer has access to, plus it's going to give them the opportunity to change scan schedules and upload test credentials for the Threat Research Center to use. And then an administrator has full functionality, including this tab that allows them to add new users and adjust current user roles. Another thing to touch on down in the lower left-hand corner here is the email options. This is a great set it and forget it feature. If you don't want to be logging into Sentinel on a daily basis, this gives you the ability to have us alert you when we find new vulnerabilities based upon a daily, weekly, or monthly schedule. So if I were to choose the weekly option, every Monday morning that vulnerability was found, I'll get an email and it'll say, hey, we found 2 new critical vulnerabilities on your application. Here's a link to check it out. And it'll give you a link to the Sentinel interface here where you can log in and see that information. Also want to touch on the site management feature of the admin tab here. What's great about this is, especially if you have many different applications under service here. This allows you to group those applications under one big banner. So if you have, say, an e-commerce team that's responsible for 3 of your applications, you can create that group here and then drag any sites that you need to over to that e-commerce team. And then when you set them up access, you set up a new person with access to that e-commerce group, they then by default have access to those 3 sites. So it makes it very handy as far as organization of employees and sites. The last thing I want to touch on here is the support link in the upper right hand corner. Accessing the support portal will give you access to our huge knowledge base. Lots of information there, white papers, who's WhiteHat, what do we do, how do we do it, as well as a ticketing system that allows you to ask any questions of our support organization, make requests, suggest improvements to the interface here, do a multitude of different things within the interface here. So that, in a nutshell, is the run-through of Sentinel. If you have any questions at all, you can visit our website, WhiteHatSec, that's SEC.com, and feel free, we've got to contact us there, and you can email us with any questions or let us know. So thank you very much for your time, and have a great day.